Hi, this is Eric Thomas from the ODOT Office of Production, and I'm going to take a look at a few Visual Basic applications that I wrote that are used to help put the cross-section quantities on the cross-section sheets. So what I've got open is just a MicroStation file with some cross-sections processed through GeoPack, and the earthworks and the seating reports have already been generated. So I'm going to start there looking at those two reports. So I have an earthwork text file here that I'll open, and this is just the 4-column output format that GeoPack will provide, and this is in a format that can be used by the cross-section sheets routines to put these values on the sheets. So column 0 is the station/region number, and the columns 1, 2, 3, and 4 are user definable, and that's all documented in our ODOT GeoPack Road Training Guide. So what I have in column 1 is the end area for cut. Column 2 is the end area for fill, and then this is the volume for cut from the station referenced here back to the previous station, and then the end areas or the volumes for the fill. So that file can be used when I clip my sheets to put those quantities on my sheet. And what I have open here is the GeoPack cross-section sheet composition tool. And under the earthwork quantity labels option, this is where I could select that file. I'll go ahead and pick that. And you can see to recognize that there are 4 columns in there. We have up to 6 configured in our ODOT XS SL file, but columns 5 and 6 are undefined, so they're ghosted here. But that's just going to give it offsets from where to place those quantities on the sheets. And this works very well. The downside to this is the quantities are placed on the sheets when you clip the sheets. And that doesn't really work in our workflow very well. We typically have to cut cross sections very early in the design process, way before we've got quantities. So the only way to get those quantities on the sheet with GeoPack functions is to reclip your sheets at a later date. And that could cause some problems. You may have done some annotation or whatever that you're going to potentially lose. So that's the GeoPack way, and we looked at, okay, how can we get those quantities on the sheets without reclipping the sheets? And while we're at it, we also wanted to include seatings quantities with it. So let me go back to my reports here, and I have a seating report, and let's take a look at that file. And you can see this is a totally different format. It's not set up in the columns with the seating values. It's set up more as a report that you'd print out. And the top of the report just has some header information with the settings that were used when I ran the report. And then as we move on down, here's the quantities. And these are split up into some columns. So looking at how it defines these columns, the first one is the station, and that's just my station number in my region. The next is the slope distance, and then it splits that into the left and right values and then adds them together for the total. And that would be our end width that we would show on our cross-section sheet. So I want that value out of this file. And then looking at the rest of the information in here, the next is my average slope distance left and right. Not really too concerned about that. And the next is my area in square yards for left, right, and both combined. So this number right here, 181, that's the area for my seating from station 53 to station 53 plus 25. So it's listed as, from the perspective of my first station here, that's an ahead station value. So that differs from my earthwork file, which was really set as the quantities were a back station value. So what we've got back in our earthwork run is we've got provisions here for columns 5 and column 6. That can be added to your earthwork file as your seating in width and in your seating area. So what I would need to do is there's a tedious long way to do this would be to take this value out of this file and this value and add them to my earthwork file. And let me open my earthwork text file again. So manually I could come in here and add a column 5 and a column 6, and manually I could come in here and put in station 63. I think the value was 65, and then since this would be a back value, it would be 0, and then at 53 plus 25, whatever that next value was in the file. Let's just use 65 again, and then whatever, again, looking back, so from 53 plus 25 back to 53, I believe the value was 185 or something like that. So that would be a very tedious process to manually add these quantities to this file. So we definitely are not going to do it that way. So what I did is I wrote a Visual Basic application to read that seating file, get the quantities, and then add those quantities to my earthwork file as columns 5 and 6 so they could be used by GeoPack to put them on the sheets. So let me start with that as far as covering our Visual Basic applications. So under our ODOT pull-down menu, I want to look at XS Utilities, and we'll look at combined quantities. So I need to select my seating file, select my earthwork file, and I'm creating a new output file. So I'll go ahead and use the select button and key in the file name here. And I'll name it with the name of my chain _ combined.txt. And we'll go ahead and apply that. And it's already gone through and read the two files and generated that new file. So looking back here, let's open that one and take a look at the information. So there's my column 5 and my column 6 and the end width of 65, looking back, 0 quantities, and then there's the 181, so from 53 plus 25 back would be 181, and 64 linear feet there for my end width on station 53. Okay, so that program will combine the quantities for you, and then in your GeoPack cross-section run, I could go pick the combined file here, and you can see now columns 5 and column 6 are available to be placed on the sheet. So I'm not going to actually run that in the sheets, but I just thought I would start with the sheet run process and make note that you can't add quantities there. And as I said, the problem is that when we're first clipping sheets, we don't typically have these quantities until much later in the process. So we looked at how can we get those quantities in a way that we could update the sheets. And what we came up with was another application that's going to come in and place a border around our cross section representing the width of our sheet, and the border also include the columns where our quantities would go. And what we'll do is we'll insert those quantities in our cross section file here, and then they'll be referenced to our sheet along with the rest of our cross section information. So let me go and place that border, and again under ODOT XS Utilities we're going to use the XS boundary application. And it's automatically going to synchronize to the first cross section in the file, and you can see it's got my job number and it's found the chain that those cross sections belong to. I can pick my scale. I'm going to be doing a 5-scale plan, and then I can pick which cross section sheet out of the ODOT standards am I putting a boundary to correspond to, and there's 3 options there. We'll just use the standard cross cell for our cross sections. I can scroll through stations here with a navigator. Just like the GeoPack Kogo navigator, it's not quite as responsive to quick button clicks just because Visual Basic is slower than MDL on the button click response. So you'll get used to the feel of that though. And you can see I've got a dotted line here. That's representing my boundary. And by default, it's starting by defining the top and bottom of the boundary by an elevation. And it's at a 5-foot increment here since I'm using a 5-scale. So I can raise the top and lower the bottom, or raise or lower either one using the buttons here. So what I need to do is define an area that encloses this cross section that will define the vertical extent of the cross section as far as how much of it will show on the cross section sheets. And that's one definite advantage of using this boundary application. When I clip my sheets, I'll tell it to find this element to define my vertical extent, and then that allows me to control exactly what my reference vertical extent is going to be on every cross section. Now I'm doing a 5-scale plan, and what I found that works real well on a 5-scale plan is if I can get 30 feet on each section, I'll end up with 3 sections per sheet, and they'll all be equally spaced, and it just makes some nicer looking sheets. So you can see I've set my upper and lower range here with a 30 feet height there between them. And I like to set the lower value so it just falls maybe 1 grid below my my station annotation here. I mean, eventually I'll probably have some underground utilities showing here, or maybe some drainage structures. So, you know, it's possible I may have to readjust a boundary later and reclip a sheet later to account for that, but this should work out fine for most projects. There's a horizontal offset value here, and that is where is the center of the boundary in relation to the center of the cross section. I can move it left or right, and that'll allow me to offset the center line of the road on the cross section sheet. So I'm just going to leave that at 0. There's an option here to draw the major grid lines. If I turn that on, when I draw the boundary, I'll also get the major grid lines drawn in the file. And really that's just used as a reference if you want it. When we build our sheets, of course the sheet cell has all the grids on there, so we'll want to make sure that level's turned off and we're not referencing that grid in there. But it is useful just to see where the grid lines are going to fall in relation to any graphics that you draw or any annotation that you draw. And I personally like to put all my annotation in the cross-section cell file, and then it's all referenced to the sheet. So that way I could reclip the sheets at any time and I'm not going to lose any annotations if I keep everything in here. But I'm going to leave the grid off for now. Now there's an option here, pause on each section. I could turn that off, and if I draw my sections, it's just going to rip through every section, and it's going to maintain this vertical elevation for the grid for every section. And if you've got a very flat project with no real vertical variance, that could work well to put these in quickly. This project's got enough vertical variance that I'm going to need to go through them one at a time and adjust my upper and lower range as needed. So I'm just going to go ahead and get started with this. Another thing I like about this is if I skip a section, if I don't put a boundary on every section, when I'm clipping sheets, since I'm going to tell it to use that boundary as the defining element, if there's no boundary on a section, it'll just skip that on the process of clipping the sheets. So I like that a lot, that you can have some extra cross sections, maybe at some key stations that you want to look at, but not necessarily show in your plan. Then just don't draw a boundary on it and it won't make it into the plan sheets. So I'm going to reset so I'm sure I'm on the first section, and I'm going to skip that one. My work starts at station 53, so I'm going to draw a boundary at 52 plus 75, so I'll show one section before my work starts. And then I'm going to adjust that down a little bit and draw that in. And I'm just going to scroll through each section one at a time, paying attention to my boundary and how it's falling in relation to the cross-section graphics. And I'll just adjust it as I go. And this will take me a minute or so to step through this project. There's not a lot of sections on this one, but I'll go ahead and take the time to put a boundary on all of them. Should have dropped the previous one. I could go back and delete it and redraw it, but I'll just go on through. And I'm going to include one station after, and I'm just going to stop. I'm not going to draw a boundary on that one. So if I go back to the beginning, you can see my boundary elevations are much lower than what I started at. But if I move forward, you can see there's the boundary that was drawn on that first section that I want to include in my plan. Okay, you can see the boundary includes my left and right columns, and those are again just visual references so you can see where they're going to fall. Now when I clip my cross sections, I actually set the left and right extent of my pattern lines to correlate to the left and right extent of a 5-scale plan sheet. Except on this first section here, I've intentionally extended the ground line. And I just did that to illustrate a point. When you clip your cross sections, anything that extends into this area, since I'm going to reference the width to include these columns, that means anything that's drawn in here will also show up on my sheet. So keep that in mind, that if you don't want your ground line extending through there, you need to either adjust your pattern lines when you're clipping your existing ground, or you need to come back in here and manually edit some graphics just to trim it off. Okay, now that I have a boundary, the next step I want to do is I want to place my earthwork quantities within these boundaries. And over here in my columns, I've got some insertion points for my cut and fill areas and volumes, and my seating width and volume. So let's go ahead and run another ODOT Visual Basic application. So under ODOT XS Utilities, this time I want to run the excess quantities application. And it's going to allow me to define each of the columns from my earthwork file and put them in the appropriate place. So I'll pick that combined file that I made, and you can see I've got 6 columns in there. And down at the bottom for each column, I can tell it what does each of these columns contain. Because again, those columns are all user definable when you're doing the earthworks. So it's possible that you may have decided to define column 1 as the fill-in area instead of the cut. So that'll allow you to come down here and change the values here of what is contained in that, and that'll control where that number goes on the boundary. So at station 53, 56 is my cut end area, so that should fall right here. So when I zoom in, I should see a 56 there, and I do, so that's good. Now the text size is controlled by my active model annotation scale. So you can see here on my model annotation scale, I've got it set to engineering 1 to 5. So if I change that, you'll see the text size. I'll probably have to go to the next station, and let's go back. So then the text size is bounced up there. So keep in mind that it is sensitive to your model annotation scale, and that's what it's going to use to determine the size. And then as far as the font, I believe the font is going to use my active text style. It's possible I hard-coded a font, but I think I just used the active text style. And level-wise for that, I believe it's going to go to the sh_text level. So I can do these one at a time. When I click on one, it'll go to that section, so I could come in and individually update a section. I can just tell it, go ahead and draw that one, and it'll go to the next section. Or I can turn off the pause button and allow it to go through and do it itself. So whichever you prefer, you can go ahead and put the quantities in the file. Now I'll go ahead and turn the pause off and just let it go on through. Okay, now that it's done processing, I'm going to go ahead and close the application. And I want to drop back into my cross-section sheets function and just kind of review how you would clip the sheets using this boundary element. So earlier this year in one of our DRRC updates, I updated the ODOT XS SL file, and I added some new options. So let's look at all the options here. So the first one is a 5-scale 1 column using the cell cross. And if I pick that option under the XS search criteria, you can see I've got some things that were predefined, and these are just some elements I'm telling Geopack to search for, and when it finds those elements will define the vertical height of this cross section. So when I'm using the 1 column option here, whether it's 5-scale, well, I should say any of these that are not extended width. If I'm using something that's not extended width, I should have called it standard width maybe. I'm going to be identifying elements that it's going to use to define the vertical extent. And horizontally, this has been set up to go out to the inside of the sheet. So the clipping area horizontally would clip here and would not include the things out here. And that's what you would use if you were going to go ahead and put your earthwork labels in using the Geopack function. Now if you're going to do what I've done and draw a boundary, you need to use one of the extended width options. So I'll go with the 5-scale 1 column extended width. I'll leave these off. And the difference is here, instead of looking for cross-section elements to define the vertical extent, I'm just using the boundary level in color 131. So look for those elements to find that to define the vertical extent. And that's, I mentioned earlier, that's very useful to control how much each cross-section will occupy vertically on the sheet. And it's also useful that if it doesn't find that element, it will just skip that cross-section. So I'm going to go ahead and click Layout Sheets here. And the reference width here, since it's extended width, will come out to the full width of the boundary and include the columns for the earthwork and seeding quantities. Okay, now that that's done processing, I'll just do a fit view in MicroStation. I can see all my sheets, and then let's just zoom in on one of these and take a look at our sheets. So I can see the boundary here, and I can see the width is extended out to include those columns over here for the seating as well. And there's what I was talking about as far as spacing. Being able to control the vertical spacing on each of these is really nice and makes for nice uniform sheets. Now I know some projects will have more vertical extent, and you may have more spacing for some sections than others. Now, a couple of those applications have a help icon on there, and I think the combined quantities does not. But if you click the help icon, all the cross-section utility applications use pretty much the same PDF file for help. So I'll just open it directly, but there is an icon on the dialog box. So under our ODOT standards and our V8I standards, VBA, there's a doc folder, and I believe there's just an XS Utilities PDF. So this covers several cross-section utilities. It covers the three that I demonstrated in this video and some others that I'm going to demonstrate in separate videos. So you can see a list of the applications that are covered, and those first three are listed there. And maybe that's all this one does cover. I'm sorry, I was incorrect. But anyway, what I wanted to point out at the end of the document is contact information. So if you have any problems with any of these programs, getting them to run or getting unexpected results, just feel free to contact us through our webpage using the link there.